Okay, just went by -2 degrees. Is that on the Earth?
That's the Earth. Now, I don't know whether we're oscillating back and forth or not, Jet, or whether it's in a continual motion. We'll have to see here.
Roger. Roger, the moon at 10 degrees. Okay, Jim, just as kind of a lead-in to this procedure that we're going to use for the mid-course burns, I'd like to say that we're going to use eggs, and it's going to be a manual burn. The attitude will be controlled manually. The start-stop on the engine will be controlled manually. So, we have a pretty good vector on you now, and it turns out you're coming in a little bit too shallow. So what that means is we're going to make our burns to come a little more steeply, and we're going to be coming in around the dark side of the Earth. Therefore, to come in more steep, our thrust should be in the direction of the sun. Does that all make sense to you?
Burns are going to be manual, and they're going to be started manually and stopped manually.
Okay, and your re-entry is around the dark side of the Earth, and since we're coming in shallow, we're going to have to burn toward the sun to make it steeper. You follow that?
Perpendicular to our flight path, and to the sun, give a steeper entry angle.
Okay, Jim, I heard you say perpendicular to your flight path, which is affirmative, and I didn't get the rest of your statement.
Perpendicular to our flight path for quarter control.
Okay, that's affirmative. So, in general terms, what we're going to have to do is to power up the eggs and bring up the eggs 8-ball, and then to set up your attitude, put the coas in the front window, guidance control will be in eggs, of course, but manually orient the spacecraft to place the center of the Earth directly out the z-axis. Then rotate about the z-axis to place the points of the crescent on the y-axis of the coas. And this will have your plus x-axis in the direction of the sun, as we discussed before. So the crescent will be up with the points down. Copy that?
Okay, Jack, we'll have to go over that again. The collapse will be in the front window. We'll place the Earth in the center of the collapse. And now let's see, the terminator of the Earth right now is parallel to the LPD, which is about parallel to our x-axis. And we'll have to rotate about 90 degrees to get our x-axis pointed towards the sun.
Okay, Jim, so we want to get the y-axis of the spacecraft parallel to the terminator by putting the points of the crescent on the y-axis.
Roger, understand. Essentially, Jack, when I stop the spacecraft again at the Earth, I'm going to have to roll in left terms, roll the spacecraft 90 degrees to get the cusp of the Earth parallel to the y-axis.
That's affirmative, Jim. You're going to have to roll 90 degrees to point your plus x-axis at the sun and put the crescent, the points of the crescent on the y-axis. The points of the crescent on the y-axis with the coas pointed at the center of the Earth will take care of your yaw and your pitch. Okay, Jim, after you get that orientation to come in a little more steeply, we perform an AGS body axis align, which is a 400 plus 5 on the data. If the AGS ball is up at this time, the AGS ball will go to 0, 0, 0. We can talk more about control modes later, but we'd recommend doing this, of course, in AGS attitude hold. Put your yaw to mode control and leave pitch and roll in pulse. Therefore, controlling your attitude with the TTCA. We don't want to use the gimbal, so have engine gimbal off. We'll make these burns at 10% thrust. We'll use a manual start and stop. For ullage, we'll use the plus X translational button, and haulage will be for 10 seconds. Over.
Okay, I understand what you're saying, but you'll have to repeat it here.
Okay, we'll perform the burn and guidance control to eggs, and mode control to attitude hold. Your attitude control switches will be roll to pulse, pitch to pulse, and yaw to mode control. So the eggs will control your yaw, and you will use the TTCA to control pitch and roll. Engine gimbal off. 10% thrust. Start and stop manual. For ullage, use the plus X translational button. 10 seconds ullage. Over.
Okay, for the burn, it'll be good guidance control ag, mode control at hole, attitude control, switches will be roll, pulse, pitch, pulse, yaw, mode control. We'll use the TTCA control for pitch and roll. Engine gimbal will be off. We'll be using 10% thrust. We'll start and stop manually. Using a 10-second ullage with the plus X translation button. And also, I thought you told me before that we're going to do a ag align to get the ball 0-0 now.
That's affirmative, Jim. After you get oriented, just the attitude that you want to burn in, do a eggs align, which is eggs body axis align, which is 400 plus 5. When you hit enter, this will bring the ball up to 0-0-0. And I want to confirm that you said engine gimbal off, OFF. Over.
Roger, confirm that engine gimbal will be off. And Jack, how long do you estimate the leg speed burn will be?
Okay, the lengths of the burn are going to be probably less than a minute, and we want to have cut off based on time, so we'll give you a burn time. And I have a P30 maneuver pad for mid-course 7 in the event that we lose comm. If you're ready to copy.
Okay, Jack, ready to copy.
Okay, Jim, P30 LEM maneuver pad. The purpose is mid-course 7. Noun 33 is 134. 5-9er. 4-2, 9er 8. Noun 81 is NA. HA is NA. HP is plus 00205. Delta VR is 00193. time, 039er. 008. 000. The rest is NA. Thrust will be at 10%. Read back.
All right, this is mid-course 7-quarter control. And if in case you lose comm, it's 134594298. 981 is NA. 42 NA plus 00205 00193. Third time 039 008 000. All the rest NA plus 10%.
Okay, Jim, that's a good readback. And in the event of lost comm, use the procedures that I gave you. It may be that between now and tomorrow, these procedures will change a little bit. So we'll go with what we've got now and stand by for something better if it comes. Over.
Okay, Jack, I'm looking at your burn pad, and I see that burning just the total WD will be 19.3 feet per second.
Okay, Jim, we verify 19.3 feet per second for 39 seconds.
Mid-course technique sounds like something that we came up with on Apollo 8.
Yeah, everybody wondered if you'd remember that. By golly, you did. And Jim, I've got a little bit more information. Maneuver pad, I've got lat long, range to go, verb 10, and GET. You got a place to copy that down and give it to you for the EMS.
Okay, stand by.
Okay, Jim, I just have the last three blocks. Noun 61. Latitude minus 02162. Longitude minus 16537. Range to go 11629er. Verb 10 36291. GET of 05G is 1424130. Read back.
Okay, Jack, I didn't get the latitude, but the longitude is minus 16567. Range to go 11629er. Velocity 36291. 1424130.
Okay, Jim, the latitude is minus 02162. I have a correction on the longitude, minus 16537. Go ahead.
Roger, Jack. The latitude is minus 2162. Longitude is minus 16537. And this goes in conjunction with that mid-course 7 pad you gave us.
That's affirmative. That means no maneuvers between now and mid-course 7. And this is a horizontal in-plane burn, plus X toward the sun, 19.3 feet per second. Jim, on the setting up the eggs, right after you do the 400 plus 5, you should do a 400 plus all balls. And one other point we want to clarify is that we know that you're sure that this burn will be made with the plus x-axis pointing at the sun, to make the entry angle steeper. You got it?
That's right, Jack. What I'm going to do is we'll stop up here to the commander's window, the coas down, and then I'm going to maneuver the spacecraft so that I have the lighted portion of the Earth at the top of the window. That is, the crest will be along the plus Y of the spacecraft, and the top of the window, out of the rendezvous window, I should be looking into the sun. That means I'll be burning towards the sun and steeping in the angle.
That's affirmed, Jim. You got the attitude right. And did your copy about doing a 400 plus all balls after you do the 400 plus 5? That is a 400 plus 5 and a 400 plus all zeros back to back.
Roger, I have copied that.
This is Apollo Control at 87 hours 29 minutes. The conversation which we just had with Jim Lovell related to a what is called a pad data for entry interface minus 8 hours. This is a more or less routine bit of information which is passed to the spacecraft at varying portions of the mission. The purpose of which is to give them the information they would need to perform a critical maneuver were they out of communication with mission control for any reason. In this particular case, this would be the burn that would put them in the proper position for re-entry. If at some point prior to entry they had lost communications with mission control. Normally, of course, the final mid-course corrections would be made with information passed up from the ground, including the spacecraft attitudes. Without communications to the spacecraft, it would be necessary for them to determine their own attitude.
This is Aquarius. I'm not too sure how long or with what force the venting is going to do to our trajectory. However, you might keep a trend on that. It appears it's been going on now for some time.
Roger, Jim. We've been taking a look at it. We haven't been able to detect it on the Doppler, however.
Roger.
Lovell's question there pertained to the...
Pretty small.
Lovell's question pertained to the venting, which he reported a short while ago. He was asking if the vent was having an effect on the trajectory and suggesting that we monitor it to determine how significant effect the venting from the service module might have on the spacecraft trajectory. As we mentioned before, we've been tracking, and Flight Dynamics Officer reported that he could detect no change in the trajectory, which could be attributed to a venting. For that reason, we would suspect that the effect of the particles coming out of the service module is minimal, and from that we would also conclude that the vent is quite small.
Okay, coming up on 87 hours and 35 minutes. We'll be there in 30 seconds. Set it for 87:35.
Just give me a hack at 88 hours.
Okay, I'll give you a hack at 88 hours. That'll be another 25 minutes.
All right, thanks.
This is Apollo Control at 87 hours, 36 minutes. The series of numbers passed up to the spacecraft several minutes ago, as we were saying, related to the pad information which the crew would use in the event they were out of communications with mission control because of some unforeseen failure, and were not able to receive from the ground the information needed to do a final mid-course correction prior to entry. In this case, Lovell would be required to get the spacecraft in the proper attitude and perform the final mid-course correction with numbers supplied previously, and those numbers were just passed up to him. The procedure for putting the spacecraft in the proper attitude would be to use the Sun and the Earth as reference points. And then once the spacecraft was in the proper attitude, he would perform the maneuver as indicated on the entry interface minus 8-hour pad, which we just read up to him. This, of course, would be a backup procedure. The normal procedure would be to use the onboard guidance equipment and numbers supplied prior to the burn from the ground. And only in the event of some unforeseen communications failure would this backup procedure be used. At the present time, Apollo 13 is 194,269 nautical miles from the Earth and traveling at a velocity of 3,771 feet per second. Coming up at 90 hours, 24 minutes, and 40 seconds, the spacecraft will cross into what is known as the Earth's sphere of influence. At this point in mission control, we'll begin calculating the spacecraft altitudes and velocities for trajectory purposes with respect to the Earth rather than with respect to the Moon. And we'll also at that point begin to see the velocity climb as a result of the ever-increasing effect of Earth's gravity on the spacecraft. Up until that point, the trajectory displays would indicate the spacecraft slowing down under the dominant effect of the lunar gravity. The height from the Earth at the point of sphere crossing would be 188,067 nautical miles, and the distance from the Moon at that time would be 33,821 nautical miles. One other bit of information from the flight dynamics officer is that the midpoint in terms of distance will occur at 119 hours, 44 minutes, 33 seconds. At that point, the spacecraft will be 110,730 nautical miles from Earth and from the Moon. At 87 hours, 39 minutes, this is Mission Control, Houston.
Sounds like the one that is best to use to me. Let me talk it over with the rest of the guys here, and we'll advise you.
Okay.
Jim, in that control mode, that sounds like the best way to go. The only thing you'll have to do is to get attitude hold in the eggs. And so before you start the maneuver, you'll have to bring the eggs up and get a 400 plus all zeros in there. And then eggs will respond in yaw when you go to mode control. That is, eggs will control your yaw in mode control, and your pitch and roll can be taken care of in pulse with a TTCA. After you get an attitude, then you'll have to redo an eggs body axis align, which is a 400 plus 5, and then go back to 400 plus all zeros again.
that was my next question. I don't want to line the X-ball 000 until I'm in position. So we use that as a primary attitude burn monitor device.
Jim, you can do a 400 plus all zeros anytime you want to. That just tells the eggs that you want it to control your attitude should you go to attitude, hold, and mode control.
Well, I understand, but then after we get to the attitude, we'll do a 400 plus 5 to get the eggs aligned, Paul, and then we'll do another 400 plus 0.
Affirmative. Thing, Jim, is while you're maneuvering to that attitude using eggs to control your yaw, if you find out en route to that attitude that you didn't quite have the yaw where you wanted it to be, you can use your ACA and tweak up the yaw, and your eggs needles go right back to zero because you zero the attitude errors.
Sounds good.
Jim, you'll be splashing down about 560 miles southeast of Samoa at about 0800 local time. The weather forecast for the area is good. 1500 scattered. High broken, 10 miles visibility. Seas will be 5-foot waves, 15 knots, and you'll be going to Samoa by boat and or aircraft. You'll spend either a night on the boat or in Samoa. Return to Ellington by 1:41 on Saturday, the following day.
Roger. Could you tell the people of the LRL to turn it off?
Oh no, we're going to do the whole bit. Say again, please, Aquarius.
Don't forget my time back at 88 hours.
Roger, that'll be about 6.5 more minutes. Jim, we got a couple of news types items. President Nixon has chosen a judge from Minnesota for the position of Associate Justice on the Supreme Court. A bill giving federal employees a 6% pay raise passed the House and went to the President. It includes military, and the air traffic controllers returned to work. might be able to work out some arrangement.
Standing by for the EO contact.
Say again, Jim?
Standing by for the 88-hour climax.
Okay, we got a minute to go. Okay, coming up on the 88-hour mark, I'll give you a 2-second delay. Stand by to mark. Mark.
I've got it.
How you doing, Jim?
Pretty good, Jack. Say, you might have the people look at our dip burn card and see what changes have to be made on a speed burn.
I heard you say look at the dips burn. You have to say what about it again, please.
Roger, Jack. You might have the people look at our dip burn card, our checklist card that we have in the lab, and see what changes might have to be put in that checklist.
Okay, the dips burn card.
Give some words on that vent that the crew report.
How you doing there, Jim?
Okay, Jack. It appears that we're going slightly divergent in our PTC attitude and pitch. I'm going to take an LPD check now, but the last time the move went around, it was way above the LPD angle. And I see the earth coming around now, which is going to be pretty low. They oscillate back and forth, but each time they seem to get a little bit farther away from the center line. He might think of some procedure to reestablish PTC if it's necessary.
Okay. Jim, the only way we know of getting as good or a better PTC than we got right now is to crank up the GNN, and we don't want to do that. So our plan is to just take whatever we get out of this and leave a run. It may turn out by the time you get to burn attitude, you'll be right where you want to be.
Okay, well, let's leave her go. course of action to set up PTC after this mid-course at 107.
We thought you'd ask that. The only thing we can try to do, Jim, is to set the thing up manually and see what happens. There must be a better answer than that. And, one course of action is to omit the mid-course and make the total mid-course, say, about 8 hours before entry. We haven't decided yet. Right now we're talking about a 7 foot per second mid-course at 104 hours. And extrapolate that down to about 8 hours before entry. We gave you a pad for that. That's about only 19 feet per second, so it doesn't change too much, and we've got all kinds of dips.
Understand. Sure like to keep this vehicle in the corridor, though.
thought of that, Jim. that tank, and we haven't been using any hydrogen, and therefore it could be venting in the overboard relief.
Right. The only other thing I can think of when I look at it in the AOT, it didn't appear to be coming from one spot. That's the only difference, although I can't see where it's coming from because it's behind the curvature of the command module. But it appears like it might be coming from more than just one spot.
Okay, thank you. We hope that when we crank up the command module tomorrow that we'll be able to, or later on today, that we'll be able to identify more closely where this is coming from. But the guidance guys say that they haven't been able to see the results of any venting in their data, and it would take a very, very small amount to perturb their data.
Yeah, that's a note of encouragement.
Chinese band going up there?
Oh, sorry, I forgot I was on hot mic.
Sounds pretty good.
This is Apollo Control at 89 hours. A short while ago, just moments ago, you heard a bit of music on the air-to-ground line coming in over the noise. Jack Swigert, the capsule communicator, or rather Jack Lousma, the capsule communicator, checked with Jim Lovell, and Jim confirmed that the music was coming down from the spacecraft. At the present time, the status aboard the spacecraft is that, as best we can tell, is that Lovell is the only one of the three crewmen who is up and about. Jack Swigert has been resting since about 82 hours ground elapsed time, and Fred Hayes began his rest period at 86 hours ground elapsed time. Lovell Lovell rested from about 82 hours until about 86 hours when he changed positions with Fred Hayes taking over the watch. At the present time, Apollo 13 is 191,187 nautical miles from Earth and traveling at a speed with respect to Earth of 3,804 feet per second. We expect to continue having quite a bit of noise on the communication line, communication circuit with the spacecraft, partially due to the fact that the spacecraft in its passive thermal control attitude is deviating somewhat from this attitude, and we do not have the optimum position on our antennas, on the spacecraft Omni antennas, for strongest reception. This situation corrects itself somewhat as the spacecraft continues to rotate at the rate of one revolution every 11 minutes, and periodically we get a combination of antenna positions on the spacecraft with respect to the antennas on ground that improves our communication situation. We do not intend to attempt to modify the spacecraft attitude with the primary guidance system powered down at this time. The feeling is that the attitude we would get by trying to reestablish the passive thermal control mode manually would probably not be as good as the one we've got right now. So the plan is to live with the communications problem and to expect that we will have periods during which it will not be possible to get usable communications because of the background noise. In mission control at this time, we are beginning the shift change, the handover. A number of flight controllers have come in for the succeeding shift. Flight Director Glenn Lunny and his black team of flight controllers will be replacing Flight Director Milton Windler and the maroon team, and that shift handover is scheduled to occur at about 7 a.m. Central Standard Time, or about 45 minutes from now. At 89 hours 3 minutes, this is Mission Control, Houston.
Jim, we've got you scheduled for an eat period about an hour ago. I suppose you're taking care of that. The other thing is we're kind of interested in knowing how long you're going to be at the stick there, if you're going to go back to bed or what.
Okay, Jack, we're going to set up a regular wash and sleep period here. Fred was up for a long time, and Mike got up a little early to relieve him. And Jack and Fred are now asleep, and we're going to let them sleep as long as they can, and then we'll have an eat period, and then I'll go back to bed for a bit, and we'll separate our schedule.
Okay, we're right at the point now where, according to the flight plan we had made up for you, that you would have all finished eating, and you and Jack would have the duty while Fred went to sleep. So essentially, according to the plan we've got, you got up about 3 or 4 hours early. And the next time that we have as a rest period for you is at 96 hours, which is 7 hours from now. And the hour before that, you can say 95 hours, all three of you would eat. And then you and Jack would hit the sack again, and Fred would have the duty until 102 hours. So we'd be glad to take care of this work-rest cycle for you.
Okay, that's good. Let me wait till they get up, or at least Jack gets up. He should be getting up before Fred. And we'll try to get back on the schedule. I hate to wake anybody up right now, though, if they're sleeping.
Okay, your choice on that. As soon as Jack gets up, I'd suggest that we go ahead and break up these lithium hydroxide canisters and make a couple of them. Jack could work on that. It's going to take 4 sets of hands, I think.